We're going to move on to internal resistance. Now you need to make a big note. This is not in your textbook. It's grade 12 work and you will be examined on it at the end of the year. Okay? And it's very important. It's one tiny little section. We've ignored internal resistance. We've said that our batteries are ideal, our conductors are ideal, but actually they're not. When we look at a cell, we can pretend that there's a resistor inside the cell. Why? Because there are ions and electrons and there's liquids and there's all sorts of things. So what actually happens is that in order for the electrons to get through the cell, they've actually got to get past all the other things in the cell first. That creates resistance. That is the internal resistance. And in cells, they're actually really small. If they're too big, then the cells are useless. So that gives us the internal resistance. That internal resistance causes a voltage drop across the battery terminal when the current flows. What does this mean? When I connect a voltmeter over a cell or a battery which is not connected in a circuit, I get a reading. That reading is known as the EMF. That is the total possible voltage for the circuit, and it's the total possible amount of energy per unit coulomb that can be given. Okay? Absolute total. Can't get more than that. However, when I complete the circuit, the potential drops. Where does that 1 volt go? Well, that 1 volt is used, it represents the amount of energy per unit coulomb that's used in order to get the electrons out of the battery in the first place. So when we complete the circuit, the voltage drops because of internal resistance. Now, internal resistors are always connected in series because you cannot connect a battery in parallel to a circuit. It's got to be connected in series. So internal resistance always increases the total resistance and makes the current get smaller. So here we have what this means. E equals EMF total. V internal is the potential that's used up inside the cell. V external is everything that happens in the circuit. Okay? So E equals EMF, I said that. V internal is because of internal resistance. V external is the potential of the external circuit. The external circuit means everything outside the battery. Okay? V internal is I times little r. V external is I times r external, which sometimes we just write as a big R. Little r means internal resistance. It's a very, very specific resistance. We put those together and we get that equation, because what we've done is EMF equals I times R plus I times R external, and you can see that I is my common factor, so I've taken it out, okay? Whether you put little r plus r external or r external plus little r makes no difference, okay? It's going to give you the same answer. So, EMF of the cell of the battery is the total amount of energy supplied per coulomb of charge in a cell, okay? EMF is measured if no current is flown, so it's got to be an open circuit. If no current is flown, then we're not doing any work. So it's the total possible amounts of energy that can be given. The symbol is that it's like a backwards 3. It has to be like that. Okay? You cannot write it like this. That means something totally different. So make note of that. Its unit is the volt, like any other potential difference. What does this mean? A battery of 12 volts can deliver a charge of 12 joules to 1 coulomb of charge. That's what the 12 volts mean. Okay? Straightforward. Let's look at a circuit. And the first answer came up. A 3 ohm resistor and a 2 ohm resistor are connected in series with a switch and a battery. When the switch is open, the battery reads 12 volts. Okay, but the switch is closed, drops to 10. So that's my EMF. That is my V external. What is the EMF? 12 volts. Okay. What is the current? So now remember, I've got two resistors in series. In series, we simply add them together. And I realized, sorry, not what I wanted to do. You can't actually read that. Okay, so let's keep going. So R total would be R1 plus R2, straightforward adding. Why? Because they're in series. So it's 5 ohms. R total would be the external, not EMF, because EMF requires, in order to use EMF, I must be using internal resistance, which I don't have. So it's going to be 5, which equals 10 over 1 I. So I equals 2 amperes. So the current that goes through the battery is 2 amperes as well. Now they want the internal resistance. So EMF is I times R plus little r. R is the same as R external. Okay, this is how it's going to be given to you on your information sheet. 12 equals 2 because we just worked out the current. 5 was the external resistance. We worked that out just now. Straightforward maths. I divided by 2 on both sides first. You didn't have to. Then I'm going to minus the 5 and I get R equals 1 ohm. When you do this, please, it's really important that you recognize that your resistance must be small. Okay? Internal resistance must be small. If you get a big answer for internal resistance, more than likely you've made a mistake. Okay? Next question. A motor car is fitted with a 12-volt battery. However, a voltmeter across the... So this is EMF. However, the voltmeter connected across the terminal shows that the potential difference drops to 8. So that's V external, while the starter motor is in use. The resistance of the wires is 0,05. This is external resistance, not internal. First thing they want, current flowing through the circuit. Well, use the things that go together. V external goes with R external. Okay? R external would be V external over I. 0,05 equals 8 divided by I. So I is 160 amperes. Very, 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 very big. But we expected that. We've done a question like this before. Now they want the internal resistance of the battery. Well, I know EMF is I times R plus R. I know what external is, okay, because we worked that out already. I know what the EMF is. It was 12. They were given to us. I would have probably divided by 160 on both sides, then minus the 0,05. It really doesn't matter, but R is 0,025. So it's tiny, which is expected. Okay, if you start getting an internal resistance of 4 or 5 ohms, something's gone very, very wrong, or quite frankly, those batteries are useless. Alright, question 16. Once again, I'm not going to read the question yet. I'm going to look at what happens. Current comes out, goes through here, gets to here, then all of it comes through. Then the current's going to split. Some of it's going to go through the 4, some of it's going to go through the 3, and some of it's going to go through the 12. Okay? Now, first of all, the reading on the voltmeter, I just want to change this to a pen because it'll be easier. So the reading on the volt, when the switch is open, the reading is 8 volts, which is my first one. When it's closed, it's equal to 7. So that value is my EMF. Then they ask you for the total resistance of the circuit. Now this is very similar to what we did earlier. We have, or in the last one, we have an unknown resistor, so I can't add all the resistors together, but I know the total external voltage, I know the total current, so I can get the total external resistance. 7 divided by 2, 3.5. Okay, so R external, 3.5. Now they want the resistance of R, that one. So you got to recognize that I would actually add R to R parallel, and those two together give me 3.5 ohms. Okay? So first thing I do is work out R parallel. So it's 1 over R1 plus 1 over R2 1 over 4 over 1 over 3 plus 1 over 12, 8 over 12. Your calculator will probably give you 2 over 3. Remember, you got to invert it to get to the end, so we get 1.5 ohms. R external would be the parallel plus R. R external is 3.5. Parallel is 1.5. R is what we're looking for, so R is 2. Okay? I know I've gone very, very quickly, but you can also pause the video and go through it again. Okay, so that's not a problem. What is the internal resistance of the battery? Well, I know that EMF is IR plus R. EMF was 8, they gave us to us. I is 2, that was also given. Okay. 3.5 was the total resistance we worked out earlier. So it didn't actually matter if you knew big R. So I divided both sides by 2. I get 0.5 ohms. Now you need to work through questions 17 and 18. Guys, it's very important that you can do these. Alright. And after this video, there's only one more to do, and that's to do with graphs. And then we are done.